Any questions over any of the homework assignments we've done so far? What we're going to over today is Cramer's rule. What we're going over today is Cramer's rule. Now, Cramer's rule is a way to solve two variable systems of equations with using determinants, what we went over yesterday. Now, whenever we use this here, we're going to take a determinant and call it determinant C. And this determinant is just the numbers that are in front of the variables. They're going to be those coefficients from the original two systems, these two equations. Now, to solve for x, we're going to take the x values and replace them with what the equation's equal to. When we're solving for x, we're going to do this thing for y. And once we simplify those, we'll have the values of x and y. Now, this will make a little bit more sense when we actually look at it in the context of a problem. So to find the value of x for this here, we're going to have a determinant on top and a determinant on bottom. Now, the numbers that go on top, we're not going to take the x values because that's what we're solving for. We're replacing those numbers with what it's equal to. For 5x, we're going to write 15 because that's what the equation's equal to. On bottom, we have 3x. Instead of writing 3, we're going to write negative 29 because that's what it's equal to. Now, the values that are attached to y will stay the same, so we'll have negative 6 and 4. Any questions on this so far? Now, we're good? Now, the denominator is just going to be the values in front of the variable. So we'll have 5, negative 6, 3, and 4. Now we just need to take those determinants. Now we can also go on and set up y's equation. Determinant on top, determinant on bottom. Now the bottom will stay the same. It's going to be 5, negative 6, 3, and 4. Let's look at the numerator, guys. So for x, we replace... I'm not a doctor, lawyer, or psychiatrist.
He always gets it. I'm failing either way, might as well try that.
You're going to do better off not taking the 0 than cheat and get a 0.
I mean, I know. Usual vessels, uterus. I mean, I know a couple. Yeah, that's a half word. Oh.
You only put like 2 words on your board bank.
If there's a word bank, I won't fail something.
Hey, did you not listen? You only put 2 words that are on that thing. 2 or 3. On the word bank.
You've been such a jerk.
All right, guys, let's focus back in here. For the numerator, the top of the equation for y, we're just switching the y values with what it's equal to. So instead of putting negative 6 and 4 where y is, we'll have 15 and negative 29. What's that? Hope you all end up with the same answer at the end. So, questions on this so far? Now, to solve, we'll solve x first. We take the determinant of the top, which is the cross method that we did yesterday. So we're going to do 15 times 4 minus negative 6 times negative 29. Would be the determinant of the top, and we would simplify that down. For the denominator, we'll do the same thing. Times 4 minus 3 times negative 6. Now at this point here, if you wanted to type all that into the calculator, you can, and it would give you an answer. Now if we did this by hand, we could do 15 times 4, which would be 60, minus negative 6 times negative 29. Before, carry the 5, 174. And on bottom, we would have 5 times 4, which is 20, minus 3 times negative 6 would be negative 18, which should be the same as plus 18, because the negative and negative would make a positive. In the numerator, 60 minus 174 would be negative 114 over 38. Now let's see if we can simplify this here. It could be nice if it does simplify evenly. And negative 114 divided by 38 is negative 3. So the value of x is negative 3. Questions on this here? Well, now we need to do the exact same thing for the y value. So we good to move on for y? Okay. So let's write this out for y. On top, we're going to have 5 times negative 29 minus 15 times 3, or 3 times 15. And this is going to be over, what would we write on bottom? And then negative 6 times 3. Didn't we already do that? Because what's the determinant for x on bottom? Say the exact same. So if we've already done it once, we don't have to redo it again. We can just write 38. So really the only determinant we really need to take is the numerator, because the denominator, we've already found the value for it. So we can do 5 times negative 29, which should be a negative 145. Negative 15 times 3 is negative 45, or 45. And if we subtract negative 145 and 45, we get negative 190. And negative 190 divided by 38 is negative 5. So what that tells us is that the solution for this here is negative 3 comma negative 5. Any questions on this here? Realistically, is this the most effective way we've done solving 2 variable systems? Not really. I mean, we could have done substitution a lot quicker than this here. We could have gotten one variable by itself, plugged it into the other equation, and solved. We could have done elimination probably a little bit quicker. Or we could turn the whole thing into a matrix and done our RREF, which we did the first time when we looked at matrices. And it would have given us the answer. This here is not the most effective way, but it is another way to solve. 4A or 4B, which one do y'all want to look at next? Because we'll only do one of them, we won't do both. 4B. let's look at this one here. So we're going to set it up. We're going to get it set up, and then we're going to use the calculator to solve. So for x, we're replacing the x values with what it's equal to. So this would be 70 and 3, and the y values would stay the same. The denominator is just going to be our coefficients of the system. In the other equation, the denominator would be the exact same, except the numerator, we would replace the y values with what it's equal to. Yes. A professional development last week or weekend on Saturday. We went to it, and they gave us those. Yep. So we can do these in the calculator. Now, looking at this here, for x and y, how many different matrices do we have listed here? Well, we do have 4 total, yes? But the denominators are the same, aren't they? So there are 4 matrices, but we only have 3 different ones, yes? So when we plug these in the calculator and define the matrices, we only need to define 3. Because the way I've been doing it, or would do it, is I'd set up A as the numerator for, we're solving for x, so 70, -5, 3, and 7. We'll set B as the numerator when we're solving for y, so 8, 70, 9, and 3. And the denominator for both we can just set as C. So 8, -5, 9, and 7. So we can pull up the graphing calculator, figure that out. But we just need to input the matrices first. So we can go second matrix, and we can go over to edit and hit enter. Well, matrix A is a 2 by 2. So it's 70, -5, 3, and 7. So we can input the first matrix. And once we get that put in, we can go second matrix over to edit. And then we can edit matrix B, which again is going to be a 2 by 2. And we can get a matrix B in, which is 8, 70, 9, and 3. And once we get that put in, we can go second matrix down to matrix C, which is a, and we can put that one in, 8, -5, 9, and 7. Any questions on how we inputted those 3 in? I have a feeling y'all are getting faster than I can type these in. Yes? Second quick. Now there's 2 ways we can put these in. Because really we're finding the determinants of each one and then dividing, yes? Well, we could take each determinant individually and then do division ourselves. Or we can put it all in at once. So to do the fraction, we can go alpha y equals enter to get the fraction. And what do we want on top? We want the determinant of a, yes, for x, because that was our top. So we go second matrix over to math and get determinant. And then we'll need second matrix A. So it'll take the determinant of matrix A. Now on bottom, we're going to go second matrix math, enter for the determinant, but we would want the determinant of which matrix? C. And then we can hit enter, and it tells us that the value of x for this is 5. Questions on how we found the value of x? Well, for the value of y, we're going to do almost the same thing, right? Except in the numerator, we don't want the determinant of a, we want the determinant of b, yes? Now, we could go alpha y equals and retype the whole thing in, yes? We almost want exactly what we have here, don't we? So instead of doing that, if you cursor up twice and select it, and then hit enter, it brings it back down. Then I can use the arrow key to arrow back over to where it's on top of matrix A and call it matrix B, and it'll replace it. Really, when I start typing numbers in, it's going to write over the top of whatever I have. So since the cursor was at A was at and I put B, it replaced it with B. I'll show you this here because right now the cursor's over the top of the parenthesis. Whatever I type now will delete that parenthesis and replace it with the new piece. So I said 5, or 8. Well, the parenthesis is gone, it put 8 in its place. So whenever we do that, but we don't need 8. I'll put the parenthesis back. We can hit enter and we get -6. So the solution for this here is 5, -6. And that's it. Questions on this here? We good with this here? Well, guess what's next? 3x3s, 3 variable systems of equations. Now, probably you're thinking this has to be more difficult than what we just did, more tedious. Because if we look at this, I'll pull up a highlighter, because our solutions are what these equations equal for the general cases M, N, and P, yes? For the 2 variable, when I solved for x, I replaced the 2 x values with what they were equal to, yes? Well, here, we do the exact same thing for y, for z. We're doing the exact same thing, the exact same setup. It's just now with 3 variables instead of 2. And really from that logic, we could almost solve a 4 variable system of equation doing the exact same thing. We're only going to look at one of these here, and we're going to do it in the calculator. We're not doing this by hand. So let's write our 3 equations for x, y, and z. So for x, again, we're replacing the x values with what it's equal to. So here it would be -14, 47, and 15. I'm going to need a little more space. Then we would have 5, -2, -6, -6, 7, -8. On bottom, we'll have 14, 5, -2, -6, -6, 7, -8. Why? We're going to do the same thing. -6, 7, -8. See if I can fit z in here. This would be 4, 3, 7, -14. No. Because the middle one would be the y values, 5, -2, -6, -14, 47, 15 over 4, 3, 7, 5, -2, -6, -6, 7, -8. So how many different matrices will we need? Does that mean we have, it would be 4, because we have 6 total, but the 3 denominators are the exact same, so we don't need it 3 times, we just need it once. Thank you. So we can define A as -14, 47, and 15. -6. We can say B is 437, 5, -2, -6, -6. C would be 4, 3, 7, 5, -2, -6, -14, 47, 15. Now we could type this into the calculator and do the same thing. I just copied it over there so I have them written down. So we plug it into the calculator. So second matrix. Over to edit matrix A. This time we have a 3 by 3. We have -14, 5, -6, 47, -2, 7, 15, -8 is our first matrix. And once we get that plugged in, we can go second matrix, over to edit, and down to B, which is a 3. And that one we have 4, -14. Good to make sure I get these typed in correct. -6. 3. Now we would have 47. 7. 15. -8. Matrix. Then we're going to edit matrix 15, which is a 3 by 3. We have 4, 5, -14, 3, -2, 15. So we've edited the first 3 so far. Now we just need to put the last one in, yes? So we can go second matrix, over to edit, and this time we're selecting matrix D. I already have this one plugged in from last hour. Actually, I have it plugged in from second hour because I never erased it from between those. But we'll build all 3 in, or all 4 in, so that we can find their determinants and solve for x, y, and z. Questions on this here? So at this point, we can go second quit. Now at this point, if we were doing this, I mean, working on it. We already have the ones done from before that we solved, yes? Now at this point, we could go alpha y equals enter and do the fraction and type it all in like we did the first time. Or I can just recall it back down. Because if we redefined what A, matrix A, B, and C are, and D, well, yes. So they make the new matrices. Now, we do have to change a few things. Because for starters, we don't want matrix CB, we want matrix A. And on bottom, we don't want matrix C anymore, we want matrix D, yes? Because D is the new bottom matrix that we're taking by. And at this point, we can hit enter, and it tells us that the value of x is 5. Well, to find the value of y, well, we can edit this here. I'm going to throw that on the floor. Second matrix, and now we're going to look at B, and we can hit enter, and you would get -2. Now, as y'all can already see, actually doing this on the graphing calculator is, I think y'all are moving a lot faster than I could ever do with this. Or at least the one on the smart board. And the last number is 4. So the solution for this here is 5, -2, 4. And that's it. Questions on this here? Yes. Okay. Yep. So the homework is on another set of worksheets. So if there's another question on this here, we'll go on and I will give you these homework sheets.